Alright guys, welcome to the third and final part of this lesson on congruence that you're working through today. So part one talked a little bit about congruence in general, and part two focused on the 5 congruence theorems that we're now allowed to use to prove that two triangles are congruent. And those are what we're going to use in proofs. We're going to focus on just those 5 and look at how we can prove it. So we're going to do 3 proofs here on this video. Feel free to write these down in your notebook and follow along, as you're going to be trying a couple of these on your own after watching this video. So this very first one has some given information for us, and our goal again is to prove that these two triangles ANX and GRX are congruent to each other. So the very first thing it tells me is that X is the midpoint of AG, and we'll keep the NR part out of it for a minute. If X is the midpoint of AG, well, that means that AX and XG are congruent to each other. I'll switch colors now, and we'll focus on the NR portion now. If X is the midpoint of NR, well, that means X is going to cut NR into 2 equal parts. So there I have 2 very important statements, okay? In addition to that, though, we need to look at things that we can assume. One thing we can always assume is vertical angles. And so right here, this in purple that I'm writing, is something we can assume through vertical angles. And so I'm planning for these proofs by writing out what I know. So now I know these are congruent, I know these are congruent, and I know these are congruent because of vertical angle congruence theorem. This means that this proof that I'm going to be writing out for you is a proof for SAS. And so that's basically what we're going to start with, okay? So I'm going to write C above for this, just because I only have 15 minutes to record this. So, the first thing that we were able to do was look at the fact that AG, and I'll switch to blue, AG was cut equally to say that AX is congruent to XG. And again, that reason was up here, the word midpoint was what told me that. So that's going to be definition of midpoint. Okay? The next thing we looked at is the fact that X was also the midpoint of NR. And so my next statement was NX is congruent to XR. And that's going to also be for the same exact reason. Definition of midpoint. Okay? The last thing that we are able to identify are these vertical angles. So anytime you see vertical angles, you can always state them. And so here I go stating it. AXN is congruent to R, X, and G. And that's going to be the vertical angle congruence theorem. So, right there, so far in this proof, I have proven everything I needed to. Remember that our strategy here was to prove this using SAS, side, angle, side. So in order for me to know that I'm ready to write my final statement to any of these proofs, I've got to check, do I have 2 pairs of sides that are congruent? Well, check and check. Is the angle that is between those 2 sides congruent? Well, check. So now I'm ready to write my final statement. So to write that final statement, we're going to say triangle ANX is congruent to triangle GRX. And the reason that we're going to write for that is which of the 5 congruence theorems did we use? So in this case, this was SAS. You just have to write the abbreviation SAS representing side, angle, side here. And thus our proof is over. So always go back and check before you write that final statement, just to make sure you gave enough information here. Okay? Pause this video if you need to reflect upon, or rewind if you need to. Go back and see any of these explanations, as I will be going through these fairly brisk. Okay? We're going to move on to the second one. And in this proof now, I'm given a couple different givens, things that we've done before, but we're going to now see in this context. I'm given that WM is parallel to KR. That's a different one, so I'm going to write the little parallel symbol there for that. And I know that angle M and angle K are the same, so I'll do that in maroon. Well, what's helpful about this one is I already know one of my congruent statements right in my given. So I don't have to go searching for 3, I only have to search now for 2. So we're trying to prove that WMR, this upper triangle, and this lower triangle are the same. Now in situations when these triangles have a common side, that reflexive property that I briefly mentioned in the previous video is a very helpful property, because guess what? WR is part of the upper triangle and WR is part of the lower triangle. So right off the bat, I now know that that's congruent. So now we already have 2/3 of our proof finished just from kind of brief conversation here. So we really have to now dive into the last thing. So let's start with our proof so far, okay? And again, I'm not condoning you to write C above in your proofs. I'm really only doing that to save time so that we can have more discussion in this video, okay? But right off the bat, I just went ahead and declared that WR is congruent to WR. So the upper WR and the lower WR, well, they're the same thing. And that's because of the reflexive property. The way to think about that, if you're having trouble visualizing that, is think about if I were to pull apart those triangles. Pull them apart from each other. Well, the WR would still be part of the upper triangle, and it would also be part of the lower triangle. But because they match up perfectly, that's why they have to be congruent to each other. Okay? So far, I have my first check mark here. I have my second check mark here. The only given that I've not addressed yet is the fact that WM and KR are parallel. And if you're having trouble seeing this, as I told you in the last chapter, turn your parallel lines so that they are horizontal. Because now what you hopefully see is, here's my parallel line, here's my transversal. Here's my transversal, here's my other parallel line. Ladies and gentlemen, what we're looking at right here is a pair of alternate interior angles. And so angle MWR and angle WRK would be just that. And so that's what we're going to need to state here. Go back, and again, anytime in this video, feel free to go back and rewind. As we start looking at some video lessons here, there will not be as much pause and wait time as there would be in a traditional class. So please pause, rewind, do what you need to do if you need to go back and see that again. Okay? So that's going to be the alternate interior angles theorem going back to our last chapter. Okay? Ladies and gentlemen, this is also enough information to finish this proof. All I got to do now is give some sort of a reason for this. So I know M and K are the same from my given. I know WR and WR are the same because of my reflexive. And I know these are the same because of alternate interior angles. So I have two angles and a side. The key is it ASA or AAS? That's the question. And the key to answer that question is the side between the two congruent angles? And that answer is no. So this is the right answer, AAS. So I'm going to be able to say, hey, guess what, guys? I wrote it wrong. WMR. That's an M right there, guys. I'll write it again. WMR is congruent to triangle RKW. And the reason I'm going to say that is angle, side. And this proof is now done as well. Okay? We have one last proof to look at in this video, and then you're going to try a couple on your own to finish up today. Okay? And let's go ahead and move to that last one now. All right? Again, pause at any time, as I've continued to say. This proof, a lot of given information. BDC is equilateral, B is the midpoint of AE, and AC is congruent to ED. Well, that right there is great because I can go ahead and mark that. And that's probably going to help me prove these triangles are congruent right off the bat. Now let's start going through some of these other givens before we write this out. If B is the midpoint of AE, well, that means that AB and BE have to now be equal. So we can go ahead and mark that as such. Okay? The last thing it says is, and let me find a different color here, BDC is equilateral. So the key is lateral. All right? Equiangular is when they're equal angles. Equilateral is when they are equal sides. And so this side, and this side are all going to be congruent for that. So right away, this should scream one particular theorem. It should scream side, side, side. And so that's what we're going to end up writing in our proof here. Okay? Remember that this triangle right here, and I'll get a highlighter out, this triangle right here and this triangle right here, I don't know why that's coming off orange, but those two triangles are the ones I'm trying to prove congruent. So we start with our given statement, okay? And again, I'm just going to write C above, since you guys can see it above as we look through this proof. So the first thing we did is we went and talked about B. So I'll do that in purple. If B is the midpoint of AE, well, that means that AB is congruent to BE. And that's through the word midpoint, the definition of midpoint. So some of these we've been using already to this point. Okay? The next important statement is that BDC is equilateral. Now, the fact that DC is equilateral, or DC is equal to the other two, is important and you're allowed to write it. But because it's irrelevant to these two triangles, I'm going to actually purposely not write it in. I'm more or less going to focus on the fact that BC is congruent to BD. Could you have written congruent to DC here? Of course. But just because I'm not really going to use it, I'm not going to write it. But as you know, and any time we've been doing these proofs, I've been telling you, hey, you can do these as you see fit. You can write in extra stuff if you need to. But at this point, we now have what we need. I have my red up here, that side, so that's these two. I have this statement, which tells me these are congruent. And I have this statement, which tells me these two are congruent. So that's everything that I need to be able to finally say that triangle ACB is indeed congruent to triangle EDB. And that's going to be through the side, side, side theorem. So again, take this time in this about 12-minute video now and pause and reflect on the three proofs we've gone through. Rewind and rewatch any of these proofs. Try them on your own before you jump into the ones on that you have to do for classwork and or homework. But look back at the different properties and things that we've done here. And we're going to obviously spend a lot more time on proofs in class beyond what you've seen in this video. Thank you for watching.